Hi friends, you're welcome to iPrime, and today I'll be showing you what is to be done in 2023 Chemistry Waec Practical. That is paper 3, Chemistry Waec Practical. Now we'll be having these two compounds, sample C, glucose, and sample D, zinc oxide, to be testing or to be working on. This is a question or likely questions you should be expecting. And the one thing I will enjoin you all to do is that you should make sure that you read the question on that day, on the day of your practical examination. And you have to do practical to be very sure. Like, you can't be giving everything I have done here. You would only be giving few from what I have done here. So make sure you take your time to read the question very well before you answer them. We have credit to be given for strict adherence to instructions, for observations precisely recorded, and for accurate inferences. All tests, observations, and inferences must be clearly entered in your answer book in ink at the time they are made. This implies that as you are taking your test, immediately record what the test is asking you to do and the observation drawn from it, as well as the inference that's made. The question states that C is an organic compound and D is an inorganic compound. Carry out the following exercises on sample C and D. Record your observations and identify any gas or gases involved. State the conclusion you draw from the result of each test. Now, this is the first question. A. That's Roman figure 2A. Put all of C into a boiling tube. Put all of C into a boiling tube and add about 10 cm cube of distilled water. Stir the mixture and test the solution with litmus paper. The first thing you have to do is, just from the test you are seeing I've made here, you have there's a C plus 10 cm cube of distilled water, then plus stir. You have an observation. It will be observed that C dissolves in water. At the line where you made the test of C plus distilled water, then plus stirring or plus stir. So the observation there should be C dissolves. C dissolves in water, and you can see there, and you can have under inference C is a soluble compound. Okay, we are yet to finish with that. You are now asked to, under that same Roman, that's a 2A, you are asked to test what the resulting solution, the solution from with a litmus paper. And bear in mind that when you are testing with litmus paper, you test with both blue and red litmus paper. So on testing the solution, we tested at the left hand side we have plus litmus. I indicated it what there's a red color plus litmus. You record the observation for that one separately. So plus litmus, and you write it separately. Then you have no effect on litmus under our observation. Like you can see, it doesn't have any effect on litmus. Then under inference, C, it forms a neutral solution. C forms a neutral solution. You can see what I've recorded there. Now, under that same 2A, we have to divide our solution, the resulting solution, into 3 portions. Okay, and dividing into 3 portions, we have first portion. To the first portion of it, you are to, that's 2A1. 2A1 to the first portion, you are to add few drops of acidified K2Cl2O7, that's potassium heptazodichromate 6. So that will be first portion of C plus acidified K2Cl2O7. We have the observation to be we have the orange color of K2Cl2O7, that is the potassium heptazodichromate 6, to be changing to what? To, like you can see there, to be changing to what? To green. So, and whenever this occurs, whenever the orange color of potassium heptazodichromate 6 changes from orange to green, that means such compound that is being added to it is a reducing agent. So under our inference, we are going to be having that C is a reducing agent. C is a reducing agent. Now you get on to the second portion of C. To the second portion of C, you have to add, that's silver nitrate, that's AgNO3, silver nitrate, AgNO3, and aqueous ammonia, that's NH3 in excess. Then that's a 1 cm cube of AgNO3, then plus ammonia in excess. That's for the second portion of C. So you are going to be having second portion of C plus AgNO3, then plus you have ammonia, NH3. Under observation, you are going to be having a silver mirror was formed inside the wall of the test tube. A silver mirror was formed. A silver mirror was formed inside the wall of the test tube. And whenever this happens, we have a reducing agent present. We have a reducing agent. So under our observation, we're going to be having C is a reducing agent. Still know that there. C is a what? A reducing agent. Now, in our later classes, we may be looking at other compounds that can have these characteristics. So that's why I'm not mentioning is a reducing sugar yet. I'm still on is a reducing agent. So now let's get on to the other part. That's to the third portion of C. Then we have to add, that's our Roman figure 2A3, 2A III. We have to add Ferlin solutions, and we're having Ferlin A and Ferlin B. That's 1 cm cube of each. Then we then warm it. And in some cases, you can have the Ferlin solution A and B already mixed together. So in a situation like that, you just add the single Ferlin solution already mixed. Or if it happens that you are having the separate, so you add Ferlin A, then followed by Ferlin B, then you warm. So in our observation, you can see there that we have a brick red precipitate formed. A brick red, that's under our observation, we have a brick red precipitate is formed. A brick red precipitate is formed. And this indicates that in our inference, we have, that means C is a reducing sugar. C is a reducing sugar. Now, to the next part of it, we are going to be having to the next part of it, we are going to be having you can be asked. These I indicated this one specially because it can also be asked. You can be asked to take a spatula full of C, a spatula full, that's a spatula full of C in a boiling tube, and then you are to add concentrated H2SO4, then warm. That'll be C plus H2SO4 concentrated, then plus warm or heat. That's under our test. Under our observation, you will see that charring will occur. Charring will occur. It will char. The compound will what? Will char. That is, turn to something like a charcoal or something to turn black. That's charring. Charring occurs. Then you can write under your observation, compounds that produce charring on adding H2SO4 are compounds that contains carbohydrates. So under our inference, we have C is a what? A carbohydrate. Now we are done with our C. We'll move on to D. Don't forget I said our D is what? Is zinc oxide. So to our zinc oxide, we have, you have to put a spatula full of D in a boiling tube. Then you heat gently and then you allow it to cool. Under observation, you'll be having, that's you can say D turns yellow when hot or when heated, and appears white when cool. So under your inference, you write that the D is what? Is zinc oxide. You can say zinc oxide present. Zinc oxide present. Now we have put the remaining portion of D. Put the remaining portion of D. Take the remaining portion of D, the one you reserved, and put in a test tube, and add about 5 cm cube of what? Of distilled water. 5 cm cube of what? Of distilled water. Then you divide it into two. Okay, before we divide it into two, we should have where or the observation of maybe testing D with what now? Litmus. We should be testing our D with what? With litmus. On testing D with litmus, we see that it changes what now? Litmus from red to blue. That's under our test. That is plus litmus. Solution D plus what? Litmus. Litmus, that's under observation. We have litmus turns that's a blue litmus paper turns what now? Red litmus paper, I mean to say, I'm sorry. Red litmus paper turns blue. Red litmus paper turns blue. And the inference is that solution D is what? Is basic or is alkaline. Then we have to the divided portion of solution D. To the first portion, you divide it into two portions. Then to the first portion, you are to add sodium hydroxide in drop, then in SS. In drop wise, then in SS. When you are being asked to add in drop, something you are being expected to test for something, and also when in SS you are expected of something. So in drop, they want to see the color, they want you to give account of the color. Then in SS, they want you to give account of the precipitate. That's if I mean to say in drop, they want you to give an account of the color of the solution or precipitate form. Then in SS, they want to test if the precipitate will dissolve or not. I repeat, please, I beg you, no, you shouldn't for any reason write PPT to represent precipitate like many students do. So you should take your time to write the precipitate in what? In full. So now we have solution D plus sodium hydroxide in drops. We have white gelatinous precipitate formed. White gelatinous precipitate formed. Okay, there's something I haven't said. In case you have been asked, if D doesn't dissolve in water, D doesn't dissolve in water. If you need to know, D doesn't dissolve in water. So you can go back to the previous one. D doesn't dissolve in water. So we're back to this. That's under our observation. D doesn't dissolve in water. That means D is an insoluble what? Compound. In case you have been asked to dissolve D in what? In water, you should be able to give that account. Then back to our sodium hydroxide plus D solution D. Then we have in drop. You should write under observation white precipitate formed. Then white precipitate, that's a white gelatinous precipitate formed. Then that means this indicates the presence of either aluminum, that's a 3 plus, that's aluminum ion, or zinc ion, that's Zn2 plus, are present. Then on adding sodium hydroxide in SS, you record for SS also. Don't forget I said in SS we want to see if the precipitate will dissolve or not. So in SS, precipitate dissolves in SS. Then that means aluminum 3 plus, aluminum ion or zinc ion, that's Zn2 plus, are present. So move on to the last part of it where we are to add the second portion, we are to add aqueous ammonia to the second portion of what? Of D. Then in drop as well, in drop wise. So in drop wise, we have white gelatinous, white precipitate formed rather, not gelatinous, white precipitate formed. White precipitate formed. Then that indicates the presence of aluminum 3 plus, aluminum ion, and or zinc ion are present. Then in SS, we have precipitate dissolve, and that indicates the presence of what? Zinc. So just take note, zinc 2 plus is present. So thank you. That is all for today on chemistry practical.